All right, guys, so in this section, we're going to continue to study our volumes of different polyhedrons. Today, we're going to focus on two new types that we have not talked about yet, which are called pyramids as well as cones. So to begin with, we're going to talk about what's called a pyramid. So a pyramid is a polyhedron with one base and lateral faces, which are isosceles triangles. So when we take a look at an example of that, we've got what are called faces. So as our first part of a pyramid, let's talk about what those are. So faces are the polygons which are on the surface, which includes the base, which is going to be one polygon, and then the lateral faces, which are all going to be triangles. So in the case of our pyramid that we've got here pictured, first let's talk about our base. So our base is going to be the part that I'm shading in blue. In other words, our base is going to either be the some kind of quadrilateral A, B, C, D. Now, in addition to that, we do also have some lateral faces. So let's talk about those. I'm just going to call those faces. So our lateral faces are any of the triangles that you can see which are going up towards the top. So I've shaded one of those in, which would be BEC. So let me go ahead and name that one first. That's triangle BEC. We also have a few more. In fact, there's 4, which are triangles AEB, as well as triangle ADE. And lastly, we have triangle CDE. Now, in addition to faces, we also have edges. So edges are where the polygon meets on a polyhedron. So those are the lines, kind of the corner edges of the polyhedron. So we have lateral edges as well as base edges. Let's go ahead and talk about the lateral edges first, which for lateral edges, I'm just going to call those LE. So lateral edges are any of the edges which are going from your base to the very top of your pyramid, which we'll define in just a moment. So for example, the one that I just highlighted, EB, would be an example of a lateral edge. So some other examples of lateral edges, we've got edge EC, as well as edge ED, and edge EA. Notice that all of those have E in them. They are all going up to that very top point at E, which we're going to define later on as the apex. Now, in addition to lateral edges, we also have what are called base edges. So let's talk about those now. So base edges are any of the edges around the base of the pyramid. So for example, one of our base edges, which I've just underlined there for us, is BC. Some other examples of base edges would be DC, as well as AB, as well as AD. As I mentioned, there is kind of one particular point which is very important, which is the very tallest point on our pyramid, which in this case is point E. That is the point where all of our lateral faces intersect, and it is what is called the apex. So the apex of this particular pyramid would be point E. Finally, we have the height. The height is the segment from our vertex to the center of our base. The slant height is a segment from the apex perpendicular to the base edge. So the difference between those two, our actual height of this particular pyramid, is again from the center of our base to our apex. So that would be this line GE. Whereas our slant height is the one on the edge of our pyramid, the one going from our perpendicular to our apex. So that would be our slant height. And that would be that line segment that I just drew in there, FE. So those are our basic parts of a pyramid. That should now allow us to go ahead and start to calculate some of the volumes for a pyramid. So when we're looking at volume of a pyramid, our formula for that is that it's going to be 1/3 our base multiplied by our height. Now, B is the area of the base, which can be different depending on whether it's a square or a triangle and so on. whereas the height's always going to be the same thing, which is from the center of our base to our apex. All right, so let's take a look at just a few examples of this. So for the first example, again, remember volume is 1/3 our base multiplied by our height. So let's talk about the area of our base first. Looking at our base, it looks like we've got our rectangle right here, which is our area for our base. And remember, to find the area for a rectangle, you just take its length multiplied by its width. So length is 21, width is 9, and so when we multiply those together, 21 multiplied by 9 tells us that our area for our base is going to be 189. As for our height, that's just going to be this part right here, which we already know has a height of 5 yards. So when we put those into our formula, we're going to take 1/3 multiplied by 189, which was what we found for the area for our base, multiplied by our height, which is going to be 5. And then just grab a calculator, type those in, and we're going to come up with a volume of 315, and then make sure to include your label, which is yards being cubed. All right. For this next example, we're going to do something very, very similar. Once again, volume formula is still the same. So 1/3 our base multiplied by our height. This time, though, our base is slightly different. This time it is a triangle, but that's okay. We're going to do kind of the same thing, just a different formula for our area for our base. Remember, for a triangle, that is going to be 1/2 its base multiplied by its height. So let's let our base be 10 and our height be 3. So then putting those in, we're going to have 1/2 multiplied by 10 multiplied by 3, which gives us an area for our base, which is going to be 15. As for our height, that's already given to us in our original diagram. That's going to be this line segment right here, which is going to be 8 centimeters. So putting those into our formula for volume, we're going to take 1/3 multiplied by our base, which is 15, multiplied by our height, which is 8, and that's going to give us a total area of, or total volume of 40 centimeters cubed. Okay. For this next one, it looks like we've got a square. Going to again use that same formula for volume, 1/3 our base multiplied by our height. In this case, our base is going to be this shaded region right here, which again is the area for our square, which we can either find one of two ways. We can just take our side and square it, or we could take length multiplied by width, same as for a rectangle, but it's probably just as easy to use side squared. In this case, our side is 10, and 10 squared is 100. Now our height in this case is going to be the 15, which was given to us in our original diagram. So we'll put those into our formula for volume. So 1/3 multiplied by our base, which was 100, multiplied by our height, which was 15. And then using a calculator to type those in, we'll come up with the volume, which is equal to 500 inches being cubed. All right. For this last example, we're going to first go ahead and find the area for our base. So again, remember volume 1/3 our base multiplied by our height. In this case, our base, again, shaded right here for us, kind of that yellow part, which I've shaded over in red, is actually once again a square since the sides are the same length. So for our base, we'll take our side and square it, which is 16 being squared, and 16 squared is 256. Now we just need to find our height. Unfortunately, we were not given our height as part of our original diagram. We're going to have to find that by looking at this triangle, actually, which is formed inside of this pyramid. Now we should know what at least part of that is, which is that this piece right here that I've gone over in green should be half of the entire side length over here, which if the entire side length is 16, half of that would be 8. So I'm just going to redraw this triangle, which I've shaded in for us right here, to make it a little bit easier to look at and work with. So here's that triangle once again. We know that this side length is 17. We know that this side length is 8. And since this side is going to be our height, eventually I'm just going to call that h. All right, so then let's go ahead and use Pythagorean theorem to figure out what our height should be for this particular triangle. And so in this case, we're going to take 8 squared plus h squared and set that equal to 17 squared. Which 8 squared is 64, plus h squared is equal to 17 squared is 289. So then we'll go ahead and subtract 64 from both sides, which will tell us that h squared is equal to 225. And now to get h by itself, just take the square root of both sides of your equation, and the square root of 225 is equal to 15. So now we know that our height was equal to 15 meters. Now let's plug everything into our volume formula to finally figure out what this volume should be. So we're taking 1/3 multiplied by our base, which was 256, multiplied by our height, which we just found was 15. And putting those into a calculator, we're going to come up with 1,280 meters cubed. Okay, so that about does it for pyramids. Let's now talk about how pyramids are very closely related to another polyhedron, which is a cone. So a cone is very much like a pyramid, has the same parts, but the base is always going to be a circle. So for our volume formula, we'll have a little bit more particular way of finding that. It won't necessarily be different like it was each time in our previous examples with pyramids. So when we talk about the parts of a cone, we still have a base, which is the circle. We still have the apex, which is the point at the very top. We still have a height, which we now sometimes will call the altitude, which is again the segment from our apex to the center of our base. And we still have a slant height, which again is the segment from our apex to the edge of the base. So we still have a lot of the same parts. We don't really talk about lateral faces because it kind of just wraps its way around. We also don't really talk too much about the edges because really the only edge is the edge that's formed by the base and the piece going up to the apex. So let's go ahead and talk about volume, and we're going to do that for a few examples, including a real-world example. So when we talk about volume of a cone, our formula for that is still the same as the volume for a pyramid, which is 1/3 its base multiplied by its height. But now if you think about it, the base should always be the same. The base is always going to be a circle. And if you think about what the area of a circle is, the area of a circle for its base is pi r squared. So if we put that into this formula volume for base, we now have a new volume formula, which is 1/3 multiplied by pi r squared multiplied by its height. And this is actually going to be the formula that we'll use on each of the examples below. So let's go ahead and take a look at some of those examples. So for the first one, we've got our height, which is 12. We also have our radius, which is equal to 8. So when we find our volume, again, that's going to be 1/3 multiplied by pi multiplied by our radius squared multiplied by our height, which is 12. And then as we simplify that, really the numbers that you want to type into your calculator are going to be the 1/3, the 8 squared, and the 12. When you type all of those in, multiply them together, you're going to get 256. Then we'll go ahead and put pi after it, and then we'll include our label, which is feet being cubed. For this next particular example, we're going to do something very similar. We still have our height, which is 8. However, for our radius, we were actually given our diameter, so we know the entire distance across the circle is 6. Again, we only want half of that, and half of 6 is 3, so that's going to be our radius. So now using our formula, again, 1/3 multiplied by pi, multiplied by our radius squared, multiplied by our height, which is 8. Once again, to simplify this, you're going to type these 3 numbers into your calculator. So you're going to type in 1/3 multiplied by 3 squared multiplied by 8, which is going to give you 24. And then we'll go ahead and put pi after it, and then include our label, which is inches cubed. So let's take a look at one last example of this so that we can have a better idea of kind of what is going on for our cones, and then we'll look at a real world example. So for this last example, we're really not given our radius, nor are we given our height. Now one of those will be a little bit easier to find than the other. Since we are given the diameter for our circle, the radius should be pretty easy to find. That's going to be half of our diameter, and half of 16 is 8. However, we don't have our height, which is this piece right here. The good news is, once again, we've already seen this type of right triangle in a previous example, with 17 as the hypotenuse and 8 as one of the side lengths. In fact, that was the one that we did for our very last pyramid, where we had 17 as our hypotenuse, 8 as one of our sides, and we found that our height was equal to 15. So normally, while we'd have to do Pythagorean theorem to be able to find that, if we use the information from our previous example, we already know that this height also has to be 15. So now we've got our height, which is 15. We've got our radius, which is 8. Let's go ahead and put those into our formula. So that's 1/3 multiplied by pi, multiplied by our radius squared, multiplied by our height, which once again is 15. And in order to simplify that, again, the same 3 numbers that we will type in, the 1/3 multiplied by 8 squared, multiplied by 15, which is 320. Then go ahead and put pi after it, and then include your label, which is centimeters being cubed. All right, for this last example, we're going to look at a real-world example of using a pyramid. So Caitlin must build a sandcastle in the form of a square pyramid for a project that she's working on, as shown below. She bought 3 bags of sand, which each contain 1,200 inches cubed of sand. Now, will she have enough sand to build our castle, or her castle, and we need to justify that with work. So we have 3 bags, each containing 1,200. That means if we take 1,200 multiplied by 3, she has 3,600 cubic inches of sand available. So we're going to have to hope that the volume of this particular pyramid is less than 3,600. So let's go ahead and find the area for our pyramid, which, remember, the formula for that is 1/3 its base multiplied by its height. So base is this square that I've shaded in red for us. So the area for our base is equal to side squared, which for this particular example is 25 being squared, and 25 squared is 625. Our height, fortunately, was given to us in our original diagram. That height is equal to 18 centimeters, or 18 inches rather. So putting those into our formula, we're going to take 1/3 multiplied by 625 multiplied by 18. And when we multiply all of those together, we're going to come up with a volume of 3,750 inches cubed. Now, 3,750 is clearly less than 3,600, so unfortunately, Caitlin does not have enough sand. All right, guys, I think that's about all we've got for today. In our next section, we'll start to talk about what the volume of spheres, as well as some composite figures. Until then, have a great rest of your day.